All right, everyone. Welcome back. We're going to have one of our keynotes of the night. This is Jeroen, also known as Sprite TM. You might know him from spritesmods.com. Does amazing hacking, lots of great stuff. Last year was a judge for the Hackaday Prize and also was in Munich with us and gave a talk that you can see online. It's about reverse engineering gaming keyboards and just he playing Snake all over it with light up. It was really, really cool. So anyways, today he's going to give a talk about the Tamagotchi Singularity, whatever that means, and we're going to hear about it now, so welcome you on to the stage.
Thank you. Okay, hello. As Chris already said, my name is Jeroen Domburg, that's the way you pronounce it. If you can pronounce that, Sprite is also fine. Worst case, hey you also works. I have this personal site called spritesmods.com, which I use to document all my projects, which are quite a few at this moment. And I live in the Netherlands. That is, I used to live in the Netherlands. I changed jobs recently, and I moved from the Netherlands to Shanghai to work for Espressif. You may know Espressif because we make a really hackable, low-cost Wi-Fi chip. There are just one big disadvantage though, and that is that if you fly you can't take that many things, and so my electronic hacking space was reduced to this. So yeah, that's not too much. So after I came to China, obviously the Chinese government wants you to fill in like in a gazillion documents in a gazillion places, and they all have to have stamps and stuff. But after that was done, I had some free time again, and I really wanted to pick up a project just to, get something going again. But a hardware project was pretty much out of the question, so what am I going to do? Well, around that same time, XKCD, the webcomic you probably all know, came out with a new comic, which is a comic in the My Hobby category, and it says, running a massive distributed computing project that simulates trillions and trillions of Tamagotchis and keeps them all constantly fed and happy. And I'm like, hey, this may be something that could be interesting that I could do that is... that has something to do with hardware that doesn't really need soldering irons and stuff. Oh, the mouse over, by the way, is the Singularity happened, but not to us. So, we probably have a bunch of people not from the 90s and non-technologists in here, so what is a Tamagotchi and what is a Singularity? Well, a Tamagotchi very quickly is a thing like this. It's basically an egg-shaped thing, mostly a keychain. It has a little LCD on there, and there's a little animal living there. And it's basically a sort of game. You're supposed to carry the Tamagotchi with you, and the goal is to keep it alive. And you do that by every time, every once in a while it bleeps and it asks for attention, and you gotta feed it, you gotta clean up its mess. You gotta entertain it, you gotta play with it, yada, 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 yada. So, last part, there actually is a devil Tamagotchi. I'm not sure if you feed it by feeding it souls, but yeah. So that's not always possible, and this was a fairly common occurrence, especially because schools at a certain point banned Tamagotchis, and all the Tamagotchis had to be left home and pretty much died. So, okay, the 90s people now probably look up from their smartphone and think, isn't this really, really, really boring? And, well, I would like to set the point straight. Yes, it is. Very much so. But you gotta remember, these were the 90s. This was the closest thing we had to a smartphone, and playing games on this wasn't invented yet. Around the time, virtual pet technology actually was already available in the form of the Pet Rock, which was very much non-interactive. Okay, so in the 90s, the Tamagotchi got a real hype, and Bandai, the creator of the things, made a hell of a lot of different types of Tamagotchis. Most of them came out in Japan, but a selection of them also made it to Europe and America. They also branched out. They made, for example, a game for multiple consoles. This is the Game Boy version. They made multiple cartoon series. They actually made a Tamagotchi movie, and they're still going somewhat strong. They adapted to the modern technology, and you can now download a Tamagotchi Android app where you can relive all your frustrations from the 90s. And They also still make new hardware. This is, for example, the 2014 version of the Tamagotchi, which I think for retro reasons, I don't know any better reason, still has the crappy black and white screen. But it now has NFC technology, so you can push two Tamagotchis together and they can interact in that way. Okay, so that is what a Tamagotchi is. So what is a singularity? Well, the singularity is a bit of a thing that's a term that's misused every now and then. But if you look at the cartoon, the thing I think is that this is basically a thing where you network a lot of Tamagotchis and you place them in a sort of virtual world where they can live, which very much reminded me of a scene from The Matrix where there are other creatures living in a virtual world. So I concluded I'm basically gonna make the Tamagotchi Matrix. Okay. Well, to create the Tamagotchi matrix, I obviously need Tamagotchis. There are a few ways to do that, and they all have a few disadvantages and advantages. Well, the first idea is to buy real Tamagotchis, which is kind of pricey because the Tamagotchis still are like 20 or 30 bucks, I believe, each. And I also need hardware to network them. And well, I can't really calculate that quickly, but 20 to 30 bucks times trillions of trillions, that's probably a bit above my pay grade. So not an option. Another idea is to run the Tamagotchi, the Game Boy game in an emulator. There actually is a Game Boy game and you can run it in an emulator, but it doesn't feel like a real Tamagotchi somehow, so it's a possibility, but no. There's also an Android application. I could maybe take that apart, but yeah, my Java scripts are slightly lacking and that wasn't really the direction I wanted to go in. Oh, but maybe there's also a way to emulate a real Tamagotchi. I mean, you know, it's just a closed thing, but maybe it's emulatable. And actually, there is. There has been a presentation. This is the Hackaday article about it, about a Natalie Silvanovic, who at the time was a researcher for RIM. I think she works for Google now. And she spent, well, literally multiple years to investigate the secrets of the Tamagotchi. And she did that really thoroughly. She opened up Tamagotchis, looked what was inside. Well, in a Tamagotchi, like most cheap-ass Chinese products, is basically a PCB with a few components and a big blob of epoxy chip in there. She decapped the epoxy chip. She actually matched that to a commercial microcontroller. She got the data sheet. She figured out a way to inject her own code to run on that microcontroller and read out the internal ROM that way. And she disassembled that and used that to decipher all the secrets of the Tamagotchi. If you ever get a chance, look up one of her presentations. They are awesome, really. Luckily, she also is a believer in open source, and she has a GitHub account where you can find all the scripts and tools, etc. she used to get where she is. She also added dumps of the Tamagotchi ROMs and of the figurines you can put on top there. So that's really useful, especially when you don't have the hardware to do it yourself. So what she found out was that the big blob basically contained a processor made by General. Sorry, I forget the name. It's basically a Chinese manufacturer. It's a really simple and cheap processor, as you would expect. Here's a block diagram. It's basically an 8-bit microprocessor. It's a 6502. It has a few timers, it has an LCD controller, very important, it has an SPI port, it has, a few extra bits and bobs. So that all is used to make the Tamagotchi, and the Tamagotchi actually has a few interfaces. Well, obviously you have the LCD and the buttons because you need that for interaction. You have the sound because the Tamagotchi needs to be irritating. You have this version of the Tamagotchi has a port where you can slot in a figurine, and the figurine actually has, in the cheaper figurines, just a connection, and in the more expensive figurines, a bit of ROM or flash that can add graphics and items, etc. to the Tamagotchi. And there is also an infrared port, which you can use to communicate with another Tamagotchi. You can hold two Tamagotchis up to each other and they can visit each other and play games and stuff. Okay, how does that map to the microcontroller? Well, very simple. You have the sound that has an amplifier into a speaker. The LCD controller is controlling the LCD, obviously. The SPI port is used to read the ROM or the flash in the figurine. There's 3 buttons that those are connected to the GPIO. There's an infrared diode and an infrared receiver also connected to the GPIO, so they're driven in software. And very important, there's an I2C EEPROM. And this generation of Tamagotchi uses the I2C EEPROM to basically checkpoint the state of the Tamagotchi every now and then. And this is really useful because if your Tamagotchi runs out of battery power or someone resets it or whatever, it can restore the state from the EEPROM, so you can get your Tamagotchi back. That's a really interesting choice, and that probably saves a lot of tears in little children. So, what can we do with this? Well, we have ROMs, we have datasheets. I can make virtual Tamagotchis. Awesome. Okay, so I needed to do some work. I needed to get a CPU emulator. Well, as I said, the thing has a 6502 core. That thing has been emulated up the wazoo. So, yeah, what I did was just Google 6502 emulator library. I got a random one from the list and used that. It's perfectly fine. There's a few things that aren't standard, like you have a bunch of timers, GPIO and interrupts, but that's not really that hard to emulate. Obviously you have an LCD controller you need to emulate because otherwise you can't see your Tamagotchi. The I2C EEPROM, very important because especially in the beginning the emulator will crash and stuff, and you wanna, you know, if the emulator crashes and you can't get your Tamagotchi back, that leads to all kinds of irritating philosophical questions. Has it died? Has it not died? Is it in limbo? I don't know. And also infrared is probably pretty nice to implement. By the way, one of the missing things is sound here. Sound is probably the most irritating thing of the Tamagotchi, and the Tamagotchi program only writes to the sound controller. It doesn't read from it. So if I don't implement it, that's perfectly fine. It'll run just happily. Okay, so that's all pretty useful. I had the datasheet, but some things weren't exactly clear. For example, what do I do if both bits here are 0? Yeah, Chinese datasheets. This is what you sometimes get. But, I can say I spent about 99% of the time on actually implementing it, and as usual, I spent the other 99% on debugging. And in the end, you basically have this. I couldn't be asked to implement a graphical user interface, but the LCD is only very small, so I just used a standard character thing to show it. And this is a Tamagotchi happily living on my console, entirely oblivious of the fact that it doesn't have any real hardware to run on. So yeah, that worked just fine. Now I just had one problem, and that's that I had to feed this Tamagotchi every time, and especially if I'm going to make a lot of it, I don't want to manually feed them every time and clean up their shit, etc. So it's time to implement an artificial intelligence, just like in the Matrix. And the artificial intelligence also, the Matrix also had an artificial intelligence that was kind of a bad guy. I didn't want a bad guy, I just want an artificial intelligence that takes care of the Tamagotchi. Feeds it whenever it's hungry, makes it happy whenever it's not, so it's more like this. Okay, so how do we implement this? Well, there are a few ways. I mean, the standard way to implement a neural network, everyone probably thinks, hey, neural network. Artificial intelligence is neural network. That's probably possible here. I mean, if you have a Google-scaled neural network, you can probably teach it how to take care of a Tamagotchi, but there are a lot of things that are obvious to you as a human because you know what the symbols are, and a neural network would have to learn those from scratch. So that would take a lot of time and probably a lot of dead Tamagotchi. So it wasn't really up to that. There's also a thing that's not usually seen as artificial intelligence, which I consider that's symbolic execution. And that's basically, you take your program, you throw it in an emulator, and you ask the emulator, okay, I want to end up in this code path, and what sort of inputs do I need? So I could use that to basically say, hey, I want my Tamagotchi to be happy. That means that this byte has to go up. And can you figure out what I have to do to make that happen? And that's a pretty interesting thing. I don't think anyone has used symbolic execution to do games like this before. But it's also pretty hard because I've only heard of symbolic execution. I've never actually tried it, and I'm not sure if there are engines for that can do 6502. If anyone wants to try this, I would be really interested in the results, because I have no idea if it could work and how it would work. So yeah, this is slightly too complicated. Well, there's a third option, and that's actually the most boring option, and that's just to manually write a bunch of ifs. If the Tamagotchi is hungry, then feed it, etc. So you basically create a hard-coded state machine to go past all the options and do whatever needed. But you need to manually code it, but yeah, in this case it can be efficient. It's sort of boring, but it's also sort of fitting, because the entire Tamagotchi itself is one big state machine. So I decided to do this, and I basically now have a state machine keeping another state machine happy. Fair enough. There's this one risk you run when you implement artificial intelligences, and actually the article on Hackaday about Tamagotchi ROM dumping, the very first comment was really, really insightful and really made me think. Yeah, there is a problem here, I don't want this feature in my artificial intelligence. So I went to look through the books on how to make sure this never happens. And luckily, a very wise academic source also had the solution for this. This is XKCD again. You just implement this, and Skynet will never happen. So I actually put this in, and if you want, you can thank me for saving the world later. Yeah, basically I implemented the state machine is actually a bit more complex than this, and after a lot of work, I basically had this. This is, if it loads, yeah, it shows. This is basically my text-based Tamagotchi emulator, and you will see the artificial intelligence kick in a few seconds. Yeah, and that's it. It'll check on the hungry and happiness of it all, and it'll see that it's hungry, so it needs to feed it. And this will fill one heart, and that's okay for the artificial intelligence, because Tamagotchis can actually get obese, and I don't want that. So, but it's still not entirely happy, so it'll see that right now, and it'll decide to fix that by playing a game with it. It has multiple options to fix it. In this case, the artificial intelligence decided to play long jumper. And the artificial intelligence is actually pretty good at this, especially if you consider that this is like 3 lines of code. But there are some frame drop issues, and that's why it misses a jump every now and then, for example here. So, but still it works pretty well. And it actually can keep a Tamagotchi alive and happy. So, okay, we have Tamagotchis, we have artificial intelligence. I mean, the only thing that's left is putting them together, right? I gotta create a virtual world to make the Tamagotchis all play with each other and interact, and also marry and have kids, because if you, in this generation of Tamagotchi, if you put your Tamagotchis together often enough, they decide to marry and have kids in a PG-13, in a kid-safe way. So how do we do that? Well, as I said before, there's an infrared sender and receiver in there. Those are basically the standard TSOP modules you also find in, for example, infrared remote controls you have in televisions. Okay, if I wanted to put that in my emulator, I first needed some support, and I wrote a little program that's called the Tama server, and it's basically a helper app, because I have a bunch of Tamagotchis. Tamagotchis aren't meant to be all connected in one big circle, because you get interference and stuff. So this is an application that basically decides, okay, this Tamagotchi wants to talk to a random other Tamagotchi, and it'll connect it. So yeah, it's pretty simple, pretty useful. Then I went on to decipher the infrared protocol, and Natalie Silvanovic already documented this protocol, and it's basically a standard TV type infrared protocol. You have a 40 kilohertz carrier wave, and at the start of the transmission that's on for 23 milliseconds and off for 5 milliseconds. Then you get a bunch of ones and zeros, and those only differ in the time that the pulse is off, like in the difference is a millisecond and a half. And finally you have an end pulse. So it's a pretty simple protocol. The only problem is if I want to implement this, it's pretty timing sensitive. If you're off by a second and a half, your zero will turn into a one. And at this point I was still running the Tamagotchis one Tamagotchi per process. So if I would allow those Tamagotchis to communicate the infrared signals directly, and for some reason, I don't know, the computer decide to spin up the hard disk or do something else, or gets a big packet incoming, then the receiving Tamagotchi may be not getting any CPU time for a millisecond or something, and that would cause the communication to fail. So I had to figure out a solution for that. Well, it's pretty simple. I mean, they're just ones and zeros. Why don't I just, first decode the ones and the zeros and then transmit that and re-modulate that on the other side? Well, that sounded like a very good idea. The problem is, when I implemented that, I got timeouts. And there's a really simple reason for that, and that's basically that the design isn't good. I'll show that now. In a normal communication, you have like in Tamagotchi sends something out over infrared, and the other Tamagotchi instantaneously receives it. Like in every bit, as soon as it's sent, the other Tamagotchi will receive it. Then the other Tamagotchi needs like in a millisecond or so of processing time, and then it'll send back a response, and everyone is happy. If I need to decode it first, then the entire thing goes a bit different. Because first of all, the Tamagotchi will send the infrared signal, which is picked up by the artificial intelligence code, which needs to decode it first. When it's decoded, the artificial intelligence code will send it over to the other artificial intelligence, which needs to re-encode the packet into infrared. But while that happens, the first Tamagotchi is waiting for a response. And it's like, this should have taken like in a millisecond or something, and I'm waiting for 10 milliseconds. This is taking too long. So while the second Tamagotchi is still receiving the signal, the first Tamagotchi is thinking, this is not going to work, and the communication fails. There's actually a surprisingly simple method to fix this. And also I got my inspiration from the Matrix movie. You just got to implement bullet time. How does this work? Can you implement bullet time? Well, it's an emulator. You can just stop an emulator and the emulator won't see time passing. So what happens now is, the first Tamagotchi will send its infrared signal to the artificial intelligence. And the artificial intelligence, as soon as it has decoded the signal, it will halt the Tamagotchi. So the other Tamagotchi, the artificial intelligence, will have time to replay the signal to the Tamagotchi. The Tamagotchi can process it, can resend the signal, its response to its own Tamagotchi. And only at that point, the first Tamagotchi continues execution. And according to that Tamagotchi, no time has passed, and it immediately gets its response, so it's entirely happy. So that worked pretty simple. I have a demo here. These are two Tamagotchis. I'll switch between the two like in a few seconds in. That's not really visible. I now tell the artificial intelligence to do an infrared visit, and it will automatically push all the buttons and ask the other Tamagotchi to also connect. This is the other Tamagotchi, and you'll see the first Tamagotchi coming over. They're happily playing and doing stuff. And at a certain point they will return to their own Tamagotchis, and everything is happy. So at this point I had to test it with multiple Tamagotchis, but I still had this entire thing running on my laptop, and a laptop is not a good environment for Tamagotchis, because every now and then I would close the Tamagotchis and the Tamagotchi's clock would be entirely off and they would sleep during the night and stuff. Jet lag Tamagotchis are no fun. Also, the Tamagotchis did use some processing time, so my battery would drain. It's not entirely good. So it was time to move them to their final place, which is my server. I have a server I rent from a company that also runs Sprite's mods. Tamagotchi.com. Oh, this is just a random server. I actually, that's an interesting story. You can nowadays rent servers over the internet without actually seeing them, without actually touching them. And I have an ISP in Germany. I think they have a bunch of underground data centers, and I just went to their website and I was like, okay, I want to have a server. And I never actually saw the server. I actually would have to look up where the server is. It's probably in one of the underground data centers, but I don't know. So I copied the Tamagotchis to that server, and that has the interesting effect that now I'm just like the rest of my generation in the fact that if you ask me where my Tamagotchis are, that I'll answer, I have no idea. They're probably in a basement somewhere. Okay, Tamagotchis run on a server, but I still need to SSH in and see the text screen. So it was time for a better user interface, make something Web 2.0, yeah. The infrastructure got modified a little bit. The Tama server now also receives UDP packets that basically contain the LCD data of the Tamagotchi. And it'll write that data to a bit of shared memory that can be read by other processes. And there's a simple PHP script that can read from that shared memory the current states of all the Tamagotchis, re-encode that to JSON and send it to a browser, so you can actually see all your little Tamagotchis happily playing around in your browser. And the server is actually online, and this is the URL it has. And with a bit of luck, if infrared works, it works. This is the actual live website, and you can see the Tamagotchis, happily going along. Somehow the image here is still and here works, but you can load it up on your laptop, and you can look at all the Tamagotchis. So the result: I have got at this moment 13 Tamagotchis running on the Tamagotchi Hive. The Tamagotchi Hive has more than 1 month of uptime. That would be more, but unfortunately RAM chip crapped out halfway. So you can't do too much with it about that. The 13 Tamagotchis in total use about 7% of the CPU in on my machine. And that actually means that on this machine by itself I can run about 200 Tamagotchis in real time. It's probably a bit more even. Some of the Tamagotchis are at their 7th generation. The artificial intelligence will also, when it gets the chance, marry them and make them have kids. So, 7 generations, so it's pretty nice. And I actually haven't had to do any interventions up till now. I uploaded it and I only looked at the Tamagotchis. With a big up to now, because I actually almost had to do an intervention at a certain time. And that is not because my code is shitty or because something crashed or something, but it's actually more of a biological thing. I only have 13 Tamagotchis. At a certain point in time, I had 12 female Tamagotchis and 1 male Tamagotchi. Can go wrong. So, okay, well, these are the results. And now I actually have one final chapter, and that is hardware. And, obviously you guys are all, this is an entire presentation. Why do you add hardware? Well, basically, Hackaday organized this conference, and they very subtle made clear that this may be a conference where you need to bring some hardware. So, okay, so I'm going to introduce to you the Tama node. It's basically a Wi-Fi powered Hive cell viewer. So you have a little LCD and you can look at all your favorite Tamagotchis on there. You don't even have to press the buttons to feed them. It's awesome. And at first I was like, oh, this is pretty simple. I mean, you take a module with Wi-Fi on it. This is a module with a chip I somehow know very well. You take a random LCD. This is a really nice memory LCD from Sharp. And then you just basically take some duct tape and connect one to the other, and you have something. And this is actually a working prototype, by the way. But this doesn't look like a Tamagotchi. It's too crisp. It doesn't have the egg shape. It looks way too this century to be a Tamagotchi. So I decided, nah, that's boring. That's boring. I'm gonna do an entire new approach. I need to have something that has the old crappy LCD, that has the round shape, that has all the buttons, that has the interesting art. I need something that really looks like a Tamagotchi. And well, what does look more like a Tamagotchi than an existing Tamagotchi? So I decided to take a Tamagotchi and wire it up to Wi-Fi so it can receive stuff from the Hive. That actually is possible because Natalie Silvanovic, as I said, she figured out a way to get code running on the Tamagotchi, and she actually built this little PCB for it. And the idea is that you have figurines like this, and you can put it on top of the PCB, and it can reprogram the flash in there. It's really useful. I could just, get one of those figurines and one of those boards. But unfortunately, I live in China, as I said, and those figurines are a very specific generation because the cheap-ass figurines only contain a jumper, and the second generation things contain, I think, a ROM, so non-flashable ROM. So I had to get myself one of these figures with flash in it, but I couldn't. But I did know that it was fairly standard SPI flash, and SPI flash is used all over the place. So I was like, maybe I can just, get a random bit of SPI flash. Here is, here isn't the SPI flash because this is the this is the ESP12. I ripped the flash out, and maybe I can just connect it to the Tamagotchi. And I actually did this. I took a flash module, I programmed an existing flash image from one of the figurines in there, hooked it up with a few bits of wire, and you can actually, you actually have access to the new games. So that is really cool, because now I can actually execute 6502 code, and I needed that if I wanted to do anything with the LCD. Again, this has all been figured out and documented by Natalie. The way it works is basically the flash has a specific format. You have a bunch of blocks with all prefixed by an opcode, which basically says what the Tamagotchi has to do with the remaining data. Show a picture, play a sound, maybe give the Tamagotchi an item, stuff like that. It's followed up sometimes by a sub-opcode. Both these two are single bytes, by the way, and then a block of data, which is the image or the sound or whatever. Also, one thing to know that image opcodes actually write data to the video memory, because the video memory is implemented as that. There's just a location in the address space of the 6502, and if you write there, the contents show up on the screen. So yeah, you can basically see it as standard RAM. And there also were some bad opcodes that if you would execute it, they would jump to somewhere random. And some opcodes actually jumped right into the video memory. So what you can do is you can take an image, encode your code in there, make sure that image is on the screen, and then execute one of those bad opcodes, which will immediately jump into your image, at which point your code will get executed. Really nice. So, this was how this is basically the design of my Wi-Fi enabled Tama node. In place of the figurine, I have my little flash chip with in there the shell code and a little piece of 6502 code that reads the button inputs, processes it as a sort of SPI input, and then takes the data and sends it to the video RAM. The buttons themselves are connected to an ESP8266 module. That's one of those chips that can do Wi-Fi. And the ESP8266 initially will, like in Twiddle with the buttons, to get into the game that starts up the 6502 code, and will then just get images from the Tama server to display on the little LCD. The hardware also is pretty simple. It's a mess of wires, but it works. You can basically see the, it doesn't have a laser, I think. You can basically see an ESP12 module up there, which is connected to the 3.3 volt from the batteries that actually runs just fine. It has a programming port in place of where the figurine would go because I cut out the PCB there anyway. And it has 3 wires running to the buttons, and that's it basically. And you can also still see the bit of flash EEPROM on top near the infrared transmitter and receiver. And well, after some programming, and I think it was like in 2 evenings or something, this is what I ended up with. So this is a Tamagotchi. I just inserted the battery, so it's still running the original Tamagotchi code. And the ESP8266 will now mess with the buttons to get into the figurine game mode, which will execute the 6502 shellcode. And unfortunately, that takes a while because there's an animation going on. I could have also cut that out, but I didn't feel like it. And as soon as the game starts, you will see, like in 1 second or so, a black screen with a bunch of pixels. That's basically the shellcode. And as soon as that shellcode actually executes, you will see a Wi-Fi signal, and then the Tamagotchi itself is open for the SPI data. So that's the shellcode, and this is my program. And now you will actually see the ESP downloading the Tamagotchi, and this is actually a Tamagotchi running on my server in Germany. And you can actually also see the other Tamagotchis. For example, this is Tamagotchi number 7, which incidentally has gotten a baby. One of the first male babies after the one male baby incident. So yeah, this works perfectly fine. So this is a really nice thing. I mean, it looks like a normal Tamagotchi. It looks entirely unmodified. You can use it to take a look at all your favorite Tamagotchis, and you don't even have to feed them. But unfortunately, there are also a few disadvantages, and that's, well, obviously this Tamagotchi is a whole lot less interactive than the original Tamagotchi, which could also be an advantage, but yeah, you know. The battery life has gone down slightly, and obviously you need a Wi-Fi connection to make it work. But those are all very minor disadvantages. If you look at the huge-ass advantage this Tamagotchi has over the original Tamagotchi, and that is that it's entirely buzzword compliant. So... So, yeah, this is the end of my presentation. Thank you all for listening. I will, as soon as I am on the flight back, which will take 13 hours, I will probably have time to write an article and put it online on spritesmods.com. In the meantime, you can take a look at the Tamagotchis here. Yeah, are there any questions? See a question? Where? I don't. Yeah. If you have a question, just raise your hand and yeah.
Well, no, go to Q&A right now.
Oh, we're going
yeah,
Q&A. Okay, that's also. Well, in that case, thank you very much.
Oh, it's not on? Okay. I know. It's like EE 101. Is it on? Thanks, that was really hilarious and awesome. So anyone who has questions for Jeroen, over there in the Q&A area. Brian's going to take him there.
Yes.
Cool. Okay,
So,
I will see you there then,
yeah.
if you have any questions.
Thanks again.
Yeah, thanks.